Hello guys, in this video I'm going to discuss converting double integral from rectangular to polar coordinates. Okay, sometimes a double integral that is difficult to evaluate in rectangular coordinates can be evaluated more easily in polar coordinates by marking the substitution x equals to r cos theta. We know that x equals to r cos theta and y equals to r sin theta, and expressing the region of integration in polar form. That is, we rewrite the double integral in rectangular coordinates as like this. Let's see what f of x comma y. So here is f of r cos theta. So instead of x we write r cos theta, and instead of y we write r sin theta. So still here it is with respect to dA. That means dx and dy. So if we want to change that, we have to change the limits. So if we change the limit, we can do that with respect to dr d theta. So while we change dA or dx dy in polar form, we get r dr d theta. Okay, let's start an example. So this is example 4. Use polar coordinates to evaluate this function. So this is the limit from -1 to 1, from 0 to root over 1 minus x squared. So here x squared plus y squared power 3 by 2 dy dx. So here we have to change the limits, and so as we change the, we do with respect to d r d theta. So how can we do that? Look at, in this problem we are starting with an iterated integral in rectangular coordinates rather than a double integral. So look at here, so -1 to 1 and integral. So before we can make the conversion to polar coordinates, we will have to identify the region of integration. So we have to identify the region where we will integrate this. To do this, we observe that for fixed x and y, integration runs from 0 to root over 1 minus x square, from 0 to root over 1 minus x square. So this is y equals to 0, and this is y equals to root over 1 minus x square, which tells us that the lower boundary of the region is the x-axis and the upper boundary of is a semicircle radius 1 centered at the region. So how is the radius 1? So here y equals to root over 1 minus x square. So if we square both sides, y square equals to 1 minus x square. So if we interchange, then x square plus y square equals to 1. So that is a circle of radius 1. So here it is the semicircle which radius is 1, from 0 to 1 here. So which tells something from the x integration, we see that x varies from -1 to 1. So we calculate that the region of integration is as shown in the figure, in this figure, and in polar coordinates this is the region swept out as r varies between 0 to 1 and theta varies between 0 to pi. So here look at this. So from my theta is from 0 to pi and r is from 0 to 1. So we have changed the limits from -1 to 1. So here it is from 0 to pi, 0 to pi, -1 to 1, which is changed to 0 to pi, and 0 to 1 minus x square, 0 to 1 minus x square, which is changed to 0 to 1. So we have changed the limits, and so here we can put r dr d theta. So now we will integrate with respect to dr d theta. So this is very simple, x square plus y square. So how we get there? So we know, let's start with the pen. R square equals to x square plus y square. So from there we can get r equals to root over x square plus y square. Sorry for this. So here look at this, power is 3 by 2, that means we can write like this, x square. So just note, that will be better, x, so we can do that. So okay, x square plus y square, so power 3. So here, so this is r cube and r drt there. So if we integrate r cube, then we'll get this. So after putting the limits to integration, we'll get this 5 by 5. So now here is the remarks. The reason the conversion to polar coordinates works so nicely in this example is that the substitution x equals to r cos theta y dot sin theta collapsed the sum x square plus y square into single term r square that we have discussed here, thereby simplifying the integrand. Whatever we see an expression involving x square plus y square in the integrand, you should consider the possibility of converting polar coordinates. So whenever we will see x square plus y square, we should try polar coordinates. So I hope this is helpful for you. This video will be helpful for you. Thanks for watching.